I apologize. We had some technical issues here with another class, so give me just a second. I'll have us up and running. Appreciate your patience today. All right, can everybody hear me and see what's going on with the slides? Good morning, Carl. All right, so here we go, folks. Thank you again. I do apologize again for the late start. Today, we're going to talk about reports that we get in, energy reports. These are going to be a multitude of different ones, but we're only going to run with about five of them. There are normal reports of the ComCheck. So we're going to get into the envelope compliance certificate, the interior lighting compliance, exterior lighting compliance, and the mechanical compliance certificate. For some of you, this may be going over old stuff and just renewing what we know and how we're reading it. For those of you who are new to the energy reading reports and the game, congratulations, we'll get you kicked off and going here. We're also going to work on the total building performance report. So that's where we're at today. Let's take a look at the energy envelope report. It contains a lot of information about the energy envelope and the project overall that helps support the energy envelope requirements. So first off, when we look at this, we want to make sure that we're on the right code cycle here. So here you can see that we're on the 21 IECC. Next up, we want to make sure the location is correct for our project. We want to make sure that we're in the right city and not out in Alabama or Delaware. You can see this is in Hobbs, New Mexico. Then I want to make sure that the climate zone is correct. So these are all things that can be modified inside the program. So that's why we definitely want to double check that what we have is working and that it is correct for our project. Also, we want to make sure that our project type is correct. So here we have new construction. We do have the ability with ComCheck to do additions and alterations, and those have different values that go in there. So we want to make sure we're using the correct project type for what we are actually doing here. We also want to remember that the glazing by code is limited to 40%. So when we take a look at our vertical glazing and wall area here, we want to make sure that's under 40%. For this project, we're at 8%. There's a lot of extra information that's given to us that the designers put in. We want to take note of this so we can tell right off the bat by this com check whether this is an all electric structure, whether it has renewable energy resources on site, whether that be wind or solar. Does it have an energy storage system? Is there an EV car charger in this or many? Does it have a heat pump? These are all things that are nice to know up front so we can verify those on the plans and verify them out in the field. So if one of these was to say true, then that means that we'd be looking for that on the plans and out in the field. Down here, we want to make sure that we have our address put in, that we have the person who's turning this in, and who our designer was on here. So this information, if we have questions, we can contact the right people, and also so we know that we're on the right site in the right city. Remember, if we are using the prescriptive path, they must comply with Section C406. This is the additional efficiency requirements. This is the section that indicates what they are doing and it shows what you need to look for on the plans and reports. And that's that efficiency package here. Remember, 406 requires at least 10 credits for new buildings. We're showing here that we're getting that 10 credits with the 35. That is correct. The surface area is based on the building elevations, not on the floor area, Carl. That's a great question. He wanted to make sure that we confirmed that the building that the vertical glazing percentage is based on surface area of the building elevations, not on the floor area. And that is absolutely correct. We're doing the surface area of the elevations. Thank you, Carl. That was a great point. All right, back here to our credits. So we can see that we have the 10 credits required and that they have 35 proposed, and it was done by the reduced lighting power here. The other thing that we have that's highlighted here is our building area. The building area lets us know the occupancy of the building, the square footage entered into the software. So we can see that this is an office, it's non-residential, and that the floor area is 12,500 square feet. Any questions on this? Okay. Here we go. We're going to get into our envelope assembly on here. This is our building description. What's going on with each part of the building? So we'll start off with the roof. On the roof assembly here, you can see that this is a building this building is being used as a retail building. What our gross area or perimeter is for the assembly. Now, one of the things to remember, this says gross area or perimeter. When we get to our slabs, slabs are done with perimeter, not with gross area if they're not heated. So we want to make sure we remember that. So we have 12,500 square feet of roof. We have 600 lineal feet on the perimeter. It gives us our R cavity values and our continuous R values for the roof. And on this one, we have an R continuous R30. It gives us the proposed U factor. The reason why we have this converted into the proposed U factor is that the computer program uses the U factor average to make sure we meet the compliance with the code with our alternatives that we use. And it gives us the budgeted U factor here. Down here, we can tell that this door is a glazed door because we have it in U factor on here. So our fenestration here says that it's 0.63 with a solar heat gain coefficient of 0.34 and a visual transmission of 1.10. Our windows. The proposed U factor column provides the info for the U factor. To find the SHGC, our solar heat gain coefficient, and our visual transmittance, we actually have to go to the description. So on the right side, you see that proposed U factor. On the left-hand side over here in the description, that's where we get that solar heat gain coefficient of 0.34 and the visual transmittance of 1.10. Green is good in ComCheck. Said that once, said it 100 times. We want to make sure that we pass. We can see right here that it tells us that the envelope passes by 3% better than code. So just a heads up, remember, if we start getting 30 or 45% above code, we may want to go in and do a little more checking on what we have going on to verify that. Um, it's possible. I've had buildings as high as 21% on the passing that were absolutely accurate, but it always just raises my eyebrows when I see something in here that's an excessive number of percentage for passing. All right, let's jump on over here to our mechanical compliance on the com check. Sorry, I'm old school. I may slip up and call this a mech check. Been doing this way too long. I'm trying to get my verbiage correct here. So, just like we do for the building envelope, we want to check all of our information up front that it's correct, that we have the correct climate zone in here and our correct project type. We want to make sure our energy code is correct. And again, that new construction there, we want to know what we're using for our efficiency packages. So you can see here, this was carried over from our building envelope that we're using the reduced lighting power instead of some of the credits that we may have been able to achieve with a high efficiency cooling package. We really want to make sure that we note this because we want to verify this on the plans as well, too. We want to make sure that what we have here matches what's on the plans and we're good to go. So when we get this, our mechanical systems list, we want to take a look at this and verify the quantity of what we have going on. Sometimes there will be a mistake here where there says that there's three HVAC units and there's only two, or maybe there's five. Just want to double check that on the mechanical schedule to make sure we have everything under control and that it's all correct. Let me go back to that a little bit. Well, no, we'll go here. So, what we can see here is that on the description of what we have happening for our HVAC equipment, we have one central furnace with a capacity of 278,000 BTUs an hour. We have a proposed efficiency of 81%. We have a required efficiency of 81%. In our cooling section here, it's telling us that we have a single package DX unit and that we have an air economizer on here. So that's where we want to make sure what's going on, that it's on the air side or a water side economizer and what's happening. So this tells us that this is an air economizer. It gives us our ratings and efficiencies for the system, and it gives us our ratings for the fans. Speaking of the fans, we have to put that information in here, and we'll find that information on here, and it'll tell us how we got this. So you can see the option used was the motor nameplate, horsepower, and fan efficiency method for this project. Down here, we can see that the fans was a single zone variable air volume, 150 CFM fan with a 1 horsepower rating and a 1 on the fan energy index. Same thing with our return fan. We have that information right there on there. This is another one for inspectors and plans examiners. Take a look at the mechanical schedule, the equipment schedule, that we have these and that they correspond, and out in the field that they are where they're supposed to be based on this. It's a nice little quick check there for you. So remember when I said green is good, red is bad. Here you can see that the fan system on this for fan system number 4 did not pass. The program tells you that. It says it fails because the energy index for the fan must be 0.95 or higher. And this one did not meet that requirement. Do we have any questions on the fans? All righty. Now we're going to jump into our interior lighting compliance checks. First off, we want to take a look at the what we have going on. What type of area is it? So when we get our certificate here, it shows us our retail sales area and our square footages, what we have for the total square footages for that area, the watts allowed by code. This is taken right out of the table. We're going to use the interior lighting number out of that section. Then we're going to multiply those together and come up with an allowed wattage of 2205. Then we're going to put in what we're actually putting in that area. And we have a ceiling LED system going in. Our fixture is 50 fixtures with a wattage of 38 watts. We take those and multiply them together to get a total of 1900. So we are allowed 2205 watts per the area. We have 1900. We are good to go. As long as it stays lower, then we're good. And this is where we'll see those lighting credits come into play. The better we are, the larger the difference between the two, the more credits you get and the more credits you're able to use. So on the interior lighting form here, you also want to make sure, just like all the time, that we meet the requirements of the energy code. This one here happens to be for Minnesota, and that our project's right, and that our project type is correct. Again, New construction, addition, interior remodel, those have to be accurate. So you can see on this one as we go down that we've got 14% better than code here. That green bar just jumps right out and lets you know that it's good to go and what the percentages are. We also have on here our lighting controls. So you can see in here we have a local control, we have a restricted manual on control, a bi-level control, and a scheduled shutoff control. So that would be our timers on there going from there. Again, these are very important things for verification in the field for inspectors and verification on the plans as a plans examiner. Making sure that we have that information correct on the plans, that it's noted in all the right places. Exterior lighting control. Do we have any questions on the interior lighting control or interior lighting certificate? I apologize. Okay. Um, Thank you guys for answering. So, what we have going on here is our exterior lighting compliance. Right off the bat, we start off just like every other one. It seems a little redundant, but we make sure that we have the right energy code up here, that we have the right project type, and that we know what's going on with our lighting area, our lighting zone. So, our lighting zone comes right here. It says it's a it's lighting zone 2, neighborhood business district LZ2. Here are the 4 different lighting zones that we get out of the code. You can see number 2 is an area that's predominantly residential, neighborhood businesses, limited nighttime usage. So that meets what we have going on here, and we're on our way. We would verify that with the plans as well and keep on going. Sorry, I forgot I had these animations in here. So here we are on this report. We've got a parking area. It lets us know what we're looking for. How many square feet? It tells us that we've got our 8,000 square feet. The allowable wattage is 0.04 watts per square foot. Our tradable watts, is this a category that's permitted to be traded? Yes, it is. So it gives us the amount of tradable wattage that we're allowed, and that comes up to our 320 watts. Our base site allowance, which comes from that lighting zone 2, was 400 watts. You can see that we have that on there. So we have 400 watts on the base plus the tradable of 320. With that tradable wattage and the base wattage, we can total up to 720 watts now for that parking area. The total there, like I said, is 720. This gives us a little more use and is a lot less restrictive than what we have out of the prescriptive path. Thus, the reason why we're using the com check to help out the malleability of the project, to be able to give it options. So when we take our math together here, we have what's going on. There's our tradable wattage. We come down here, we see that we have 10 fixtures at 65 watts per fixture, and that comes out to 650 watts. So there we go. We've got that 10 fixtures, like I said, 65 watts per fixture at 650 watts. 650 watts is our total project value. Our original value that we were allowed was 720. So 650 is less than 720. We're doing great here. It tells us that we're good and we're on our way. We'll see that little green bar at the bottom and keep on running here. Do we have any questions at all on the com checks, envelopes, exterior lighting, interior lighting, mechanical com check reports? Is there anything that I went over too fast that you guys would like me to touch on? All right. Well, if you do have any questions, please put them in the chat, and we'll be able to get back to them. I'm going to take a quick second here and put my email in the chat. So that way, if you guys do have any questions later on or at any time, please give me a ring, send me an email. We can help you out here. So we've gone through our com checks. Next up is our total building performance reports. So when we do our total building performance path, we need to receive these reports, and they're in-depth reports with a lot of calculations on them. We want to make sure that those calculations are correct and that they have the information that we're looking for and need on the plans. This will also help, again, as always, out in the field, being able to take a look at this and what's happening. There is no real standardized report on this, so we grabbed one on here to show you what we're looking for. So right off the bat, we need that cover page, cover letter, telling us the basic information of the building, the location, if it passes, and by what percentage it's passed by. And that's based on the reference design. So per table, or excuse me, per section C407.2, we need to make sure that our design that's submitted is 85% less than the reference design. So here we go. On here, you can see we've got the project name, and we can see that it's a 162,991 square foot, four-story above grade multifamily building. With this information, it's going to comply with the 21 IECC per section 407 for the total building. It tells us right here in the written statement that they're predicting a 21.2% better annual energy cost. The energy modeling is in the table. We have an inspection checklist for the mandatory requirements in table 2. It shows that we have the inspection checklist for the envelope in table 3, the lighting in table 4, and it gives us the standard reference design building model. The appendix describes the energy modeling approach and includes the input and output reports of the energy from the analysis. So that is a very succinct and complete project cover page. On here, you can see that they also tell us that we have an annual energy cost includes the 42 kilowatt PV system, which is 5% of the total building energy cost. That allows them to reduce the energy that they're consuming with that there. You can see that the reference building was projected to have $180,000 worth of energy. The proposed is 141,996 with that PV system installed. We are good to go. We had the 21.2% better. That's better than the 15% required by 407. So we are on our way. That's a great way to start this. If for some reason this was a 14% change, so we were only 14% better, they would have to resubmit. There's no use even going through the rest of the report because it's going to fail. We do have to meet that 15% right off the bat. So just out of curiosity, how many of you get these reports when they're trying to do this path? Anyone had one of these that was fun and interesting? Is this something you see a lot of or not very often, if at all? Todd Cooper, you asked if they add a PV system, does that make it easier to pass? Yes, it does. That's a great question. By adding PV systems, the energy that's created allows you to deduct that from your annual costs, but it has to be at the same rate of the deduction as you would buy that energy. So any electricity that you would buy would come from there and be added to the production you have to take off of that total. All right, John says he does get these sometimes. So just curious as to where we all stand on this. And that's a great idea too, Todd. Todd says that for the larger projects, they've been using an energy firm to do all of their modeling. So, energy firms are great resources to use. And as long as they submit all the design criteria, we are good to go. So, what we have here is the requirement that we verify what's going on with our annual energy costs and how we got it and what got it from. So in this project, we get our energy from a group called EIA. You can see on here that their cost per kilowatt hour is 0.126, 12.6 cents per kilowatt hour, and their cost per therm is a dollar 2.3 cents. We need to have that information to be able to verify that what they're doing is a accurate number. We can check that number through uh, the internet and have them supply other documentation if we feel that it's incorrect. And we can actually go to that EIA group and verify it as well. Also on here, they have to give us our location and climate data. For this project, we're up in Denver, and we have it gives us our latitude, our longitude, gives us the elevation, our heating days, our cooling days, the heating design temperature, the cooling design dry bulb, the cooling design wet bulb, and what zone it's in. That's very important. So we make sure that we're accurate with our information. Again, on the plans, and that we're doing this in the correct area. If this was a 1A climate zone here in Denver, we would definitely have problems with it. Same thing if it was a climate zone 6. So we are good to go on this one. When we get our plan review, we need to make sure that all the information listed in the design energy should be on the plans. I'll take the design energy measures part of the report to verify the information is placed on the plans. I also use this to ensure items were not missing and that items need to be were not missing and the items were not included in the report, and the opposite is true. So did we have everything on there on the plans? Did we miss something? Did we miss the design climate zone? Did we miss the information as to the equipment on here? Or do we have extras? Does the report have stuff that's not on the plans? We need to verify that. We also need to make sure that the common area and floors matches for the multifamily. They have to have insulation for fire rating for horizontal assemblies, but that's not part of the thermal envelope, so that doesn't count unless it is. So if we had an exterior corridor, then we might include that insulation. But if everything's inside the exterior walls and we have corridors running through there, and we see that we have insulation in a floor system that's on the report, that would have to be taken off so we can make sure that the report is correct because that's not part of the thermal envelope. So again, this is one of those points in time when we're doing that plan review that we have to know where that thermal envelope's at so we can make sure that the report reads correctly. On this, you can see that in this project, we have an R20 closed spray cell foam that's below deck and blown in insulation to fill up the rest of that cavity. We have the exterior walls as an R21 and 2x6 wood studs. We have trash, stair, and elevator cores that are 8-inch filled CMUs with no insulation. This is where that trade-off path comes in and shows what we have happening because by code, that CMU wall should have an R11.4 on it, but we don't have insulation on this project, so we're allowed to do those trade-offs like that. We're using just the insulation out of the mass wall itself, and that's it. We verify our glazing. We verify our floor slabs, what they are and how they work. This tells us about our lighting and interior loads, how we got those loads. We did the space by space on this one. It gives us our HVAC systems. It tells us where we're using individual units and where we're using just community units for like the corridors and the amenities. And it also lets us know that we have that PV system there for our production of on-site energy. Next up will be our inspection checklist. This is for the mandatory compliance portion, and this is how we verify that what we're getting is what is on the plans and that we have everything that we need. One of the things you'll see is it tells us that our continuous air barrier is per C402.5.1, and then it tells us where to find that at. This one happens to be in the spec book. So that's where we would go. This saves a lot of time for plans examiners and for inspectors. You know exactly where to go to find that information. You don't have to turn through a 2,500 page spec book trying to hunt down where this information's at. You can see the thermal envelope and the specifications book again. Our air leakage and fenestration per 40254 is in the specifications book. Rooms containing fuel burning appliances are outside of the thermal envelope or enclosed and isolated per 40255. Well, we'll find that on sheet P2-1.1A. So instead of going to the spec book, it's on the plans. This is one of my favorite parts of these reports is being able to just jump to those pages, any questions, and verify what we have. You can see that there's no loading docks on this down here, that our vestibules are here, and that they're provided on sheet A1-1.1. Great information here. Our calculations and our heating calculations and cooling loads, where to find that information at. It lets us know that there's no data center and that we're don't have to comply with section C403.2. So a lot of information comes off of this. It takes a little bit of time to read through it, but doing so will save you time in the long run. So we're going to continue with the checklist here, and you can see it just continues right on down. It goes into our HVAC systems on this particular portion. We've got the controls, the thermostatic, the dead bands, that they all comply. Where do we find that information? Well, again, that's on sheet M6-0.1 through M6-0.4. It's great having this information there. We can verify specifically what's happening, orders of operation. We're good to go. In this building, we do not have the economizer fault detection and diagnostics, so we weren't able to use that as a digital controls credit. It lets us know that. We continue onward here. We see our ventilation and exhaust system comes out of the spec book. Our fan and fan controls comes out of the spec book. We do not have any large diameter fans per C403.9. The refrigeration equipment performance and efficiencies per 403.11 are not required. No commercial refrigerators, no walk-in coolers. This is not a restaurant. The HVAC construction and insulation provisions as required by 403.12 are duct insulation, our duct construction, and our piping insulation. How many of you have been out in the field and you've come up on a set of pipes that's got insulation on it and you're not sure if it's the right amount? This will tell you where to go. Right there in the spec book, we are on our way. We need to make sure that we have all of these inspection checklists as well. It does us no good to only get parts and pieces of the inspection checklist. Um, Obviously, if it's not there as a plans examiner, we don't have all of this, we should be failing this and asking for the rest of those documents. If you get out in the field, somebody's torn out page 3, got to find that, get it back in there for the inspections. It's here, it's a tool. We need to be able to use that tool to make our life easier. And it also makes the contractor's life easier. They can see what's going on, what they need to do, how they need to comply. If there's any change orders, then they can put those in and reference that sheet or that spec and let the designer know what it is. So across the board, it helps everybody out. We'll continue on to our water heating, our service water heating. So this lets us know what we have, where to find it at. On that page six, P6 point dash 0.1 for the requirements for compliance with 402, heat traps for 404.3, that's in the spec book. Installation of water heater piping, that's in the spec book. The supply piping requirements, that's in the spec book. So we can just keep on rocking right on down. You can see here that we do not have an economizer on the water heat recovery systems per C404.7. We don't have a swimming pool or spa. That's a great one. I was on a project once going out doing an inspection. First thing I noticed is that they had a huge swim spa out there, and it wasn't on the plans. It wasn't anywhere else. Unfortunately, they had not put it in correctly and did not have it noted, so we had to hold the project up a little bit and get that taken care of. So this is one of those things. If I have time before I get out and do those inspections, I will take a look at this information and have it in my back pocket, and I'll ask the contractors on site, hey, do we have a pool going in here? I didn't see one on the plans, but I want to make sure. How about a hot tub? So you can use that information to get ahead of the game. And if they say, yes, we do, then we can expedite that system for those changes and keep it going. So we know that in the future, we're going to have that, and we can make that decision right there on the spot. Do we need to shut the project down? Is it critical? Or is it something that they can put in as a deferred submittal? On here, we have our required power and lighting. Lets us know what the controls are on the page E0-00. The lighting for plant growth, we don't have a grow house in here, so there's no reason for that. Does our exterior lighting comply? What's the page it's on? Dwelling electric meters provided per 405.6. Remember, each unit has to have its own electric meter. This shows us where it's at and how it works. The electrical transformer requirements of 405.7. Any electric motor efficiencies. So that would be where we'd be looking for the nameplates and verifying the nameplates match those specs. Any vertical or horizontal transportation systems and equipments comply with 405.9. Elevators, escalators, those type of things. Did we meet the requirements for the voltage drop? The one everybody loves, the automatic receptacle control. Does it comply? And the page it's on. As we know, that's a huge one to have. We can verify out in the field that it meets those plans correctly, and we're on our way to getting the project going and completed. We have our checklist for the envelope. This is obviously an important one. It tells us where we're going to find all of our installation values, where it's located at, the details for it, and how it complies. You can see on here that the construction type, we have a 21 IEC standard reference design, and then we have our proposed design. So they don't match exactly. The construction type says we need that R30 insulation entirely above deck. On this project, we chose to go below deck with an R20 and then fill in the rest of the cavity to make that equivalent R value. Again, our proposed standard tells us that the square footage is the same as the standard, reference standard. I'm sorry. Got a little happy with our standards there. We can see that the reference standard starts off with a 0.32, excuse me, a 0.032, and that our design is going to use a 0.021. So we're going to put in much better windows than what's required. We have our absorbance for the solar properties of the building and our emittance, and those that are referenced and what we're proposing. Our mass walls, you can see here in the construction type for walls above grade, the code requires that R11.4 continuous. But if we come over here to our proposed design, our trash stair and elevator cores have the 8-inch filled CMUs with no insulation. So part of those windows trade-offs takes care of that insulation value for the mass walls. We can see that we started off with a construction type of steel framed walls with an R13 plus an R10 continuous. Our proposed is going to be an R21 batt insulation in 2x6 wood studs. One of our trade-offs there would be our thermal conductance. Those wood studs don't conduct the energy through them as fast as the steel studs. Our gross area, that's the same. Our U factors for mass walls for the steel comes down here. We can see that that is right here. Our U factors are 0.90. We got the 0.63 for the, oh, excuse me, 0.90 is for our mass. We have the 0.58 here. Our steel studs, don't know why they put that one in backwards, but it works. Little mental gymnastics. Our steel studs here are the 0.055 U factor. We have a 0.063. So here, our walls are not near as good as what's required, but with the other trade-offs and the uh, efficiencies of the equipment, we're able to keep going with that. Our solar properties were there. Our slab on grade, unheated, R20 for 24 inches, unheated and none. Our F factors here. Oh, sorry about that, Francois. Had the chat in the way, folks. I do apologize about that. So we'll come back down here on the opaque doors. It tells us that they're swinging. That gives us our area. It gives us our U factors. We're good to go. Next up is the vertical fenestration. We can see what the average is. Based upon that surface area of the vertical area, we have a 21% average. It lets us know what we have for the required operable, and it lets us know what we have in here for our fenestration as a U.29. Then we'll continue onwards for our lighting and HVAC checks. Again, we have our reference standard on this one right here on the left side, our proposed standard, and where it's found at. It gives us all of our requirements, what we're looking at for our exterior total kilowatts, what we're actually using. 10.5 kilowatts on the exterior is what's allowed. We're using 2.5 kilowatts. We have the 0.45 watts per square foot allowed inside the building area. We're averaging 0.285 watts per square foot. This is where that trade-off system works well and allows us to make those changes with the insulation. We have our requirements for the system. Here you can see that our mechanical ventilation requires 15,540 CFMs. That's a huge one to make sure that that's correct on our plans. That 15,540 right there. We come down here, we can see that we have an economizer in here. It's using a fixed dry bulb of greater than 75%. Our heating systems, when we get here, we can see what the fuel systems are. Natural gas and electric, natural gas and electric. It tells us that we're using packaged terminal heat pumps, that we have that dedicated DX cooling and natural gas heating in the corridors, that our amenities are the packaged terminal heat pumps for the amenity area, and that our mechanical storage vestibules and stairs are electric heaters. Again, as a plans examiner, this is the bomb for being able to go through and verify our information on here. We can see our efficiencies down here, what's proposed, and whether or not they meet. So we can verify whether that's part of the trade-offs or not. And here we have the rest of the cooling system. We are using electric on here. Again, this shows us what we have going for our residential packages as being the terminal heat pumps. The corridors are the dedicated DX cooling systems, and that our amenities is using the terminal heat pumps. It's a packaged terminal heat pump. When we come over to our proposed, we can see that in the residential areas, we're using the packaged terminal heat pump. We can see the corridors are using that DX cooling and natural heating, but in the amenity, we decided to go with a split heat pump with supplemental electric resistance heating. That way we know exactly what we're looking for and where it's at. The efficiencies are in here. You can see the residential units are required to be at 9.5 to 10.14 EER. We're actually using a 10.3 to a 13.0 EER. Obviously, this is part of that trade-off system that allows us to make modifications in other places, allows the lesser amount of insulation, and we keep on going there. Our service water heating, we're going to use the fuel type as natural gas. This is going to be a gas-fired water heater. It's proposed at 95%. It's required to be 80%. Our capacity is four of them at 500 MBH. And our water fixtures, it goes into that much depth that we know what's going on with our water fixtures here. We have 1.5 gallon per minute showers, 1.2 gallon per minute lavs, and 1.0 gallons per minute kitchen faucets and fixtures. So, do we have any questions? Things are going through there at a fairly good clip. Is there anything specifically you'd like to know about on these reports? All righty. Well, I want to thank you guys. Oh, Carl says typically our AE firms uses prescriptive path requirements as a schematic design benchmark, but we submit under the performance path in order to accommodate project-specific issues. Our standard operating procedure is to generate an initial performance path check report during the design development phase, then finalize it prior to issuing permit documents to the AHJ. That's a great way to work that, Carl. That's a very grounded system there. Anyone else have any comments or questions? Okay, well, I do want to say thank you for everything. Remember, we do have the survey. Please fill that critter out. It helps us become better. I'll give you back a couple minutes in your day. And again, I do apologize for the technical difficulties up front. I'll hang on here if there's any other questions. Otherwise, have a great day, folks. Thank you so much for attending. Appreciate y'all. Thank you, everybody. Have a great day. I'm going to end it.